Welcome back. In this video, we are going to discuss how to write the Python code to compute the radius of curvature of the given curve. Okay. Here, there are two types of problems. One is if the given curve is a Cartesian curve, that means the variables are x and y. Then how to find the radius of curvature. Then just write the formula. If you have the Cartesian curve, then I have to find y1 and y2. Then use the formula rho equal to 1 plus y1 square whole power 3 by 2 divided by y2. This is the formula we have to use in the case of Cartesian curve. If we look into the working procedure, suppose you are given with a Cartesian curve and you need to find the variables, I mean radius of curvature. Then first call the library function. That's the first step. Then define variables, symbols I have to define. Then find derivatives. I have to find the first and second derivative of y. Then use formula. Then print the answer. Okay. If you want to find the radius of curvature at some particular point, then I have to call that value. Say you can call that value as t naught or t1, whatever that. Then substitute that value, substitute t naught and print. So this is the procedure I have to follow. T naught or x naught, whatever you can call. If you have polar curve r equal to r of theta, then the formula is rho equal to r1 square plus, oh sorry, r square, r square plus r1 square whole power 3 by 2 divided by r square plus 2r1 square minus r into r2. So look into the working procedure. First, we have to call the library function, then define symbols, then find the derivatives r1 and r2, then use the formula, then use the point, call that point as t naught or x naught, whatever you want, then substitute that value and then print the answer. So this is the procedure I have to follow to write the Python code. Okay, let me execute a program. Let me open the console. Yes. So first, call from simping import star. Okay. So first, let me consider the Cartesian curve. I'm going to find the radius of curvature of y equal to ax square plus bx plus c. Okay. So y, a, b, c, x. There are five symbols. I have to define all these here. X, comma y, comma a, comma b, comma c equal to symbols of single quote x, comma y, comma a, comma b, comma c. Symbols are defined. Write the curve y equal to ax square, a star x double star 2 ax square plus bx plus c. Then find first derivative y1 equal to diff of y comma x. Just differentiate y with respect to x. Then y2 equal to diff of y1 comma x to find the second derivative. Then write the formula rho rho equal to open double bracket 1 plus y1 square whole power 3 by 2, or let me write 1.5 divided by, let me close this bracket here only, nothing to worry. Okay, in the denominator y2. So just write y2. Now the bracket is closed. Yes, this is the formula. Then You have to print this value. Print the radius of curvature is simplify of rho. So this is the radius of curvature. Here there is one more point. We have to find the radius of curvature at x equal to 1 by 2a square root of a square minus 1 minus b. Okay. For that, I had to add two more commands. One is first I have to write the value of x. Let a equal to, or we can call that value as, okay, let me call a only, equal to rho, I mean at the expression rho, I had to substitute SUBS to which variable, to x, comma, value 1 divided by 2a, write this within bracket, 1 divided by 2a star square root QRT of QRT of a square minus 1 minus b. Then we have to simplify this value, call that as rho 1 equal to simplify of a. You can call any, you can use any alphabet here, not a, or you can use T or anything you want. Let me check the bracket. So 1 divided by 2a into SQRT of a square minus 1. This here I should close to bracket. Okay. Print the radius of curvature the radius of curvature is rho, okay, is rho1 rho 1 units. This I should write within single quote. Yes. So this is the radius of curvature. The second line gives the radius of curvature at the given point, and this is the radius of curvature at x. Whatever the value you wish to take for x can be taken. So this is how you can compute the radius of curvature of the given curve. Suppose you are given with the polar curve r equal to f of theta. Then the same procedure I have to follow. Say I'm going to find the radius of curvature of the curve r equal to 4 into 1 plus cos t at t equal to 5 by 2. Right. Then the procedure is first from simply import star then t comma r are the two variables equal to symbols t within single quote I should write t comma r. Then I have to define the curve r equal to 4 star 1 plus cos t. So we have defined the curve. We have to find the derivatives. R1 equal to differentiate r with respect to t. Then R2 equal to differentiate R1 with respect to t. So we got first and second derivatives. Now the formula RHO equal to R square plus R1 square whole power 3 by 2, that is 1.5 divided by R square plus 2R1 square minus R2. So this will compute the value of the radius of curvature. We need to find the radius of curvature at the point pi by 2. First, I should call that value. Say, okay, I'm convenient with the direct statement. Rho 1 equal to at RHO, at the expression RHO, substitute which value I have to substitute and to which variable. For t, substitute pi by 2. If this will not run, then you may need to write float of pi by 2. Let me check. Print the radius of curvature is float value. So 4 point. I want answer for 4 digits. So 4.4 F units. I have to print percentage RHO 1. So 3.7712 units. This is the radius of curvature of the curve r equal to 1 plus cos t. So in this way, we can find the radius of curvature of different curves at different points. Okay. In the next video, we shall meet with the one more